to the second demo that we're doing for the Digital Library of the Middle East Prototype Project. To start, we're going to talk about what we've actually been able to pull in so far from some of our data providers. Currently, we've got materials from 5 institutions, Princeton University, Stanford, Penn Libraries, the Metropolitan Museum of Art, the American Numismatic Society, the Penn Museum, and Harvard University. So we'll talk a little bit more about how we've implemented the metadata mappings and give you a little bit more insight into that in just a bit. All these items are now live, and I think we've got about 54,000 or so that are live right now.
During this sprint, in addition to aggregating metadata from our data providers, we've begun to focus on user interface improvements to improve the visual polish of the website. Most notably, that includes the footer at the bottom of every page, which includes information and context about the Digital Library of the Middle East and ways to contact the project team. As we've started aggregating more data into the project, we've discovered that many of our providers' metadata does not include references to thumbnail images. For aggregated objects without these thumbnails, we're now able to show a placeholder image instead. For resources with imagery, we're able to display those thumbnails as part of our search results views and on the show page for these objects. The image is a link to the original data provider's website. One other improvement you may notice is on the show pages, we've decided to hide many of the tools available from Blacklight in order to make more room to display our visual content.
On this page, you will see a spreadsheet, and each column represents one of the pipelines that we've defined for import. The first step of the import is a harvest step, and that's what these numbers represent, the number of files that we're going to harvest into each pipeline. The second step after harvesting all these resources is to transform them into what we're calling JSON intermediate representation resources. And in that way, something like the Met CSV, which has a single file, can get expanded into several thousand records. We have a blue button at the top of the page, and if you click that, that will start a new harvest in the background. The harvesting step usually takes about a minute, and then the transforming step takes maybe the next 20 minutes or so. And then if we already have harvested all the data we wanted to, but we've changed the mapping, so we merely want to retransform them, you click the gray button next to the harvest you want, and it will re-index everything, so all the stuff will show up in the UI.
When receiving records from a new provider, one of the first things we do is try to figure out both what reader class we might need, whether it's CSV or XML or something else, and then we also look at the record and do some very basic preliminary analysis of field usage. If it's using something like MODS, which is a shared or community-based schema, we can try to base off the understanding of the schema, but for CSVs, we have to do local analysis to figure out our mappings. The mappings are first captured in this spreadsheet. So in this spreadsheet, we will map whatever, so this is MODS XML, so this is XPath to indicate a very specific field within that XML document to a DLME intermediate representation field. And this is where we can also put some notes on if there has to be further logic to do lookups. So for contributors and creators, for example, we do want to check the role term within the MODS, that would be rows 6 and 7. We do want to check the role terms where present in the MODS to determine if the name field should become a contributor in DLME or a creator. We have logic, sort of lookup logic for this for a couple fields where we want to map to either controlled vocabularies, which is what we try to do for languages or for our types values. or if we're doing lookups to get things like thumbnails, which can become institution-specific logic. And then this mapping is used to guide the implementation within our extension of Traject. For mods, you can see we have tried to pull out everything that can be universal for any mods XML that we receive. And leveraging our extensions to Traject, we can map to a particular field, either a complete XPath pulled from mods, which you can see with, for example, the mods. The CHO identifier on row 25 is just pulling from a particular XPath for each mods record that we process. You can also see we add some mod-specific lookups or logic to our own macros. So for language, we have a normalized language function, that's row 28. That ends up in a mods macro to check where we know in mods that a language value would occur, and then to match that against what Traject calls a translation map to get the controlled values that we would like. These macros are in part to try to hide some of the more code-like extensions we have to do to these mappings and to keep the actual config files themselves simple enough that someone who's not a Rubyist could still write this and have a basic understanding of what the mapping is doing. So the mods config is generic for mods. We still have to have institution or provider specific logic. Here you can see the Stanford mods config, which should extend that generic mods with things that are specific to Stanford mods that we receive. In particular, for the Stanford mods, we have added a fair amount of lookups to get IIIF information based off of how Stanford publishes their metadata and their IIIF manifest. This would be added also for the MET CSV, where we have to do lookups or any other institution specific, so that we can try to reuse the core mappings across institutions. And the only thing we have to change as we get more mods XML or TEI XML or FGDC or other is what the institution specifically needs.
And after running through Traject, we output these DLME JSON intermediate representations, which are a consistent format across the data providers, and allowing us to build a user interface that can come to expect particular data to exist in particular fields. This IR is then indexed into Solr in a variety of ways to provide access for full text searching, for faceting, for multilingual transformations, and that makes it available in the DLME user interface.